Whether you're building a new PC system or whether you're adding a new hard drive to an existing PC system, it's critical that you understand the relationship between these three concepts: the hard disk, the partition, and the volume. Let's begin by talking about partitions. A partition is really nothing more than a logical division of the available storage space on a hard disk drive. A hard drive is not the partition, and a partition is not the hard drive. Partitions are identified by 16-bit entries that make up the partition table located in the master boot record of that drive. The key thing to understand is that a hard disk can have a single partition on it that encompasses the entire drive, or multiple partitions that divide up the storage space on the hard drive. Either way is fine, it just depends on what you want the system to be able to do. For example, let's suppose that we have a hard disk drive installed in a Windows system. The cylinder that you see here represents the storage space available on that hard disk drive. In this example, I've taken this hard disk drive and I've created one single partition on it that encompasses all of the storage space. If this were the only hard disk drive installed in a PC system, then this partition would be represented, at least under Windows, as C. Creating a single partition that encompasses an entire drive is not the only option that we have. In this example, I have the same hard disk drive, but I've created two partitions on it, one here and one here. This allows me to divide the hard disk drive into two separate chunks, which allows me to do a variety of different things. If I'm using a single operating system like Windows, I can assign each partition a separate drive letter. For example, I could access the first partition as C and the second partition as D. Even though I have one physical drive in the system, I would access each partition on that drive through a separate drive letter. Another option would be to create a file system on my first partition and access it as C. Then, on the second partition, I would create a file system on it and access it through a directory in the C file system. For example, I could create a directory named xspace on C, and then mount this partition in this directory. As long as I'm on the C drive over here, and I'm in a directory other than xspace, I'm accessing the storage available in this first partition. But as soon as I switch directories over into the xspace directory, I'm no longer working in this partition. I'm now working in the storage space encompassed by the second partition on the drive. All of your Linux systems address multiple partitions in exactly this way. Instead of having drive letters, a Linux system will mount your available storage space and all your partitions in a particular directory in the file system, just as we have done here on Windows. On a storage device, you can have a maximum of 4 primary partitions. This limitation is imposed by the way the master boot record is structured. It isn't associated with an operating system. For example, let's suppose we have one single hard disk in the system. I can have a maximum of 4 partitions. If I had 2 hard disks in the system, then I can have 8 primary partitions, 4 per device. Remember that 4 per disk rule. You don't have to use all 4 if you don't want to. You can have as few as 1 on a particular drive. In the past, the operating system had to be in the first primary partition. Now, the operating system files can be installed on any partition on any hard disk in the system with one caveat, and that is that the operating system boot files must still reside on a primary partition. It doesn't matter which disk it's on, and it doesn't have to be the first one, it just has to be on a primary partition. Now, I just said that you can only have 4 partitions per disk. Well, there is a little exception to that rule, and that exception is a special type of partition called an extended partition, and it allows you to break the 4 partition rule. An extended partition is not required, so you don't have to use it if you don't want to, but if you need to have more than 4 partitions on a particular hard disk drive, then an extended partition comes in handy. However, there are some limitations to an extended partition. An extended partition is not bootable, so your operating system files cannot reside in an extended partition. Your bootloader won't be able to boot the system if you put your system files within an extended partition. Also, you can only have 1 extended partition per storage device. Now, we can have up to 4 primaries, but if we choose to use an extended partition, we can only have 1 extended partition. So, that means we can have up to 3 primary partitions and 1 extended partition on a hard disk drive. We could also have just 1 primary partition and 1 extended partition. Or, if we had 2 hard disks installed in a computer system, we could have 2 extended partitions, 1 on each hard disk. Also, you cannot create an extended partition on a hard disk drive that already has 4 primary partitions. Extended partitions cannot be directly formatted. Instead, we create logical partitions within the extended partition. These logical partitions reside within one extended partition. We can create up to 24 logical partitions within one extended partition. This is how you break the 4 partitions per hard disk rule. You're still limited to 4 partitions when you're dealing with primary and extended, but once you start creating logical partitions within a single extended partition, you can have up to 24 separate logical partitions within one single extended partition. After you create your logical partitions within the extended partition, you can format each logical partition just as if it were a primary partition with a file system. After the partitions are formatted, the operating system doesn't know the difference between a logical partition within an extended partition and a standard primary partition. For example, let's suppose that I have a single hard disk drive on my system. I create one partition on this drive that encompasses about half of the drive, and I create it as a primary partition. Then, I create a file system on it, and I install my operating system here. This is my C drive. In addition, let's suppose I create an extended partition encompassing the second half of the drive, and within that extended partition, I create 3 logical partitions. By doing this, I have essentially 4 different partitions in my system, even though I really only have 2 real partitions, a primary and an extended. But because I've created logical partitions within the extended, I've created 4 partitions on the single hard disk drive. I can manage these logical partitions in the extended partition just as if they were regular partitions. I can assign them drive letters, I can format each logical partition within a file system, and I can address the first one as the D drive, the second one as the E drive, and the third one as an F drive. Another option is to create 3 separate directories within my primary partition on my C drive. In this example, I create the xspace1, xspace2, and xspace3 directories, and I mount each of my logical partitions as directories, xspace1, xspace2, and xspace3. Then, when we access any of these directories, we're no longer accessing the storage space on the primary partition, but the storage space within each of these respective logical partitions. Another aspect of partitioning that you need to understand is active partitions. The hard drive on your system must have at least one active partition. An active partition is the partition that your bootloader uses to load the operating system files from. You can only boot an operating system from a partition that's set to active. So, if your operating system files are in a partition that's not set to active, you can't boot the system. You'll need to set one of your existing primary partitions to be the active partition, and then put your operating system files on it. Let's take a look at how this boot up process works for an active partition. On startup, your BIOS or UEFI loads a bootstrap program that loads the master boot record into memory. The master boot record then reads the partition table to see which of the primary partitions has been marked as the active partition. The master boot record then uses the partitioning information to find sector 0 of the active primary partition. This is the boot sector for that primary partition. After that's done, the master boot record then loads the boot application operating system file located in the boot sector of the active primary partition. And at that point, the BIOS is done. The BIOS doesn't need to do any more, so it turns over control of the boot process to the operating system itself. As you can see, it's very important that you have the correct partition on the hard disk drive marked as the active partition. This same principle applies to Linux as well as Windows. Let's say that your system is not using all of its hard disk storage space. For example, suppose you have a 200 gigabyte hard drive and you're only using 50 gigabytes of it. If so, you can shrink the 200 gigabyte partition down to 100 gigabytes and create a new volume using the remaining 100 gigabytes of disk storage space as another volume. You can reduce the space used by primary partitions and logical drives by shrinking them into an adjacent, contiguous space on the same disk. If you need an additional partition but don't have additional disks, you can shrink the existing partition from the end of the volume to create new unallocated space that can be used for a new partition. When you shrink a partition, ordinary files are automatically relocated on the disk to create the new unallocated space. There is no need to reformat the hard disk to shrink the partition. But keep in mind that the shrink operation can be blocked by the presence of certain file types. Also, if the partition is a raw partition, a partition without a file system on it, and it contains data, like a database file, then shrinking the partition could destroy the data. Now, just creating a partition on a hard disk drive does not allow you to use the storage space within that partition. Before you can access that storage space, you have to format that partition with a file system. This is done by creating a volume. A volume can encompass a single partition on a single disk, and a volume can span multiple partitions on a single disk. It can also span multiple partitions on multiple disks. There are a couple of things that you have to understand in order to make this work. The first thing you need to understand is that within Windows, there are two different types of disks, a basic disk and a dynamic disk. A basic disk can contain primary partitions and an extended partition with logical partitions defined within it on a basic disk. A basic disk can have up to 4 partitions, including extended partitions. One of the key benefits of basic disks is the fact that they can be accessed by any operating system. For example, a basic disk can be accessed by DOS, Windows, and Linux. Because we're creating our volumes on a basic disk, the volumes are called basic volumes. A basic disk can only host basic volumes. Let's talk about some of the limitations associated with using basic volumes. Basic volume is limited to only using partitions within the same single basic disk. In other words, a basic volume cannot span disks. You can't use space from a partition on one disk and space from a different partition on a different disk in a basic volume. For example, if we had 2 hard disk drives in our system, and each hard disk drive had a partition on it, and they were both basic disks, then we could not create a basic volume that spans both of them. It just doesn't work. When we're dealing with a basic disk, we have to have a one-to-one relationship between partitions and volumes. Also, if you have 2 partitions on a hard disk drive, then you can create 2 basic volumes. If you need to create a volume in a Windows system that spans multiple partitions on multiple hard disk drives in that system, you can convert your basic disks into dynamic disks. This is done using one of 2 different utilities within Windows. You can do it using disk management, or you can also use the diskpart command line utility to convert a basic disk into a dynamic disk. Now, if you do this, then remember that if you already have basic volumes created on your basic disks, they will also be all converted to dynamic volumes. This is important because dynamic disks cannot be accessed by older versions of Windows. Dynamic disks provide a lot of features that basic disks don't have. First of all, you can create a volume that spans multiple dynamic disks. Whenever you create a volume from either one or more dynamic disks, you've created a dynamic volume. Remember, if you create a volume on a basic disk, you've created a basic volume. If you create a volume on a dynamic disk, then you've created a dynamic volume. For example, let's suppose we have 2 hard disk drives in this system. We have hard disk drive A over here and a hard disk drive B over here. On hard disk A, I created 2 partitions. This is my first primary partition, and this is my second primary partition, and I converted this disk to be a dynamic disk. On hard disk B, I also created 2 primary partitions, and I've converted this disk to be a dynamic disk as well. I format this first partition within a file system, and that is now my C drive. This is where my operating system files will be installed. For the remaining partitions, including the second partition on the first disk, as well as both partitions on the second disk, I can create a dynamic volume that consumes the space from all 3 of these partitions. Now, in order to do this, a dynamic disk uses a hidden database. This hidden database tracks which partitions are assigned to which particular dynamic volume. That way, we don't break our volume. There are a lot of advantages to using dynamic volumes as opposed to basic volumes. One of the key ones is the ability to increase the amount of available storage within a volume. If you've got basic volumes in a system and you're running out of disk space, your only option is to install a new hard disk drive in the system, create a partition on it, create a basic volume from that partition, and then copy all of the data from the old basic volume to the new basic volume. This can be a painful process and it takes a lot of time to complete. With dynamic volumes, the process of adding space is easy. All I have to do is install the new hard disk in the system and convert it to be a dynamic disk, create a partition on that new dynamic disk, and then allocate the space in that partition to the existing volume. Dynamic disk also allows you to create RAID arrays, where basic disks don't. Dynamic disks are very powerful. So, that's it for this lesson. Let's review the main points we've talked about. We learned about the relationship between hard disks, partitions, and volumes. We began by talking about the different types of partitions that you can create on a hard disk drive. We talked about primary partitions, extended partitions, and logical partitions. And then we talked about the different types of volumes you can create, like basic and dynamic volumes.